Right, so here is your first problem. So yeah, you need to work this out on a piece of paper, take a picture of it, and then send me that picture via Teams. So here's the situation. Here's a table, floor. Yeah, it's going to be essentially the same problem that we just did. Okay. And then here is a block sitting here. So let's say that this guy, M1, is equal to 1/2 kilogram. And it's tied to a string, and that goes around a pulley. And here's M2. M2 is, guess what, 1 kilogram. And so when the blocks are released from rest, what is their acceleration going to be? Also, what's the tension in the string? Ooh. So to get the tension, I'm not sure if we did that in the example problem I just gave. Basically, though, look at, once I find the acceleration, look at this block 1, for example. So that tension, remember, is the only force acting on M1. So that means that T is M1A. So whatever value you get for A, plug it in over here, multiply by M1, and that gives you the tension. That is the tension in both parts of the string. So there's problem 1. Next. Okay. Yes, it's the same table, except it's red now. And so, you guessed it. So there's a string going over this pulley that's attached to these two masses, okay? So let's say that M1 equals 1 kilogram, okay? And when I release these two blocks from rest, the acceleration turns out to be 0.5 g. Or if we use 10 for little g, that acceleration is 5 meters per second squared. The question is, can you guess what the question is? Of course you can. What is the value of M2? Such that the system accelerates at 5 meters per second squared. Yes, you could do this problem, okay? We just went through this entire, how to set this thing up. The way you set this up is identical to what we did in the past, except now you're solving for a different variable, is all. So there you go, okay? Enjoy. Again, take a picture of this, all right? And then send me that picture by the end of the day via Teams. And then here's just one more extra special problem for you. Okay. So here is, M1 attached to a string, attached to another mass, M2. So let's say that M1 is 2 kilograms and M2 is 1 kilogram. But yikes, guess what? There's friction on this block. It's not equal to 0. There's friction between the block and this table. In fact, there's so much friction that when I release the system, both blocks just sit there, right? Yeah, Both blocks sit there when I release them because of friction between this block and the table. The question is, how large is that frictional force such that both blocks remain motionless? Work this problem out, take a picture of it, and then send it to me via Teams. All right, thank you.